Hi everybody, welcome back to my channel Analytics Brain. My name is Shobit Tyagi and I'm today here, we'll be discussing and showing you the demo around how we can extract the information from the unstructured data. So if you guys have seen my previous videos where I had, taken the sample insurance documents primarily in PDF, right, where we had used some sort of regex or, a rule-based expressions to extract the information from those documents. Now let's try to improve that extraction process and try to use the spaCy. spaCy by mean that we will be doing the named entity recognition or named entity extraction from the document, and for that we will be using the spaCy library. Again guys, if you have not know what is spaCy, how it works, what are the packages, which library we can use for in NLP, for all those things, so please go and check my previous videos which I had uploaded, where I had given the hands-on understanding about the spaCy while extracting the information, primarily the entities from the document. Okay guys, so let's start into the code base. Let's look into the code base that how we can extract the information from the PDF document using the combination of spaCy plus the regex library. So let's quickly look into the code. So if you guys can see my screen, I had already created the code for the data extraction piece. And before going into the code, let's look into the data first. So if you had seen my previous videos, I had already discussed with you the data, the type of the data we have. So basically we have different type of files. So let's look into the file number one. So we have a PDF document which contains information about the patient case history. Okay, so it is the medical insurance claim report which contains some small paragraph which contains the textual information. Then we have couple of tables, and each table is holding the patient related information. So first table is holding the information related to demographics, where it contains the name of the patient, its date of birth, gender, primary addresses. It's also talking about the phone numbers, email, policy number, claim number, doctor name, diagnosis, and diagnosis summary. Then we have another table which is talking about doctor diagnosis and information. So what's the diagnosis, what is the name of the doctor we have, what are the diagnosis summary. Then we have another table which is talking about the premium breakup, something like that. Okay, then we have another table which is talking about claim charges. So hospital charges is $2,500. So this is how this is a sample PDF we had created. So it's not the correct format, it's just an example or a sample PDF which I had created to give you an understanding about the extraction piece. So don't worry about the structure of this report, that whether it's correct or not, but yes, it is just an example to give you guys an understanding about the data extraction. Then I had already created another report related to health insurance policy documents, which contains the information something like this, where we have policyholder name, number, providers, amount, premium amount, policy start date, policy end date, and then we have some text which contains some description about the policy. We have renewal information, renewal date, premium date, again with some description about the renewal. We have a claim history, claim when that person has taken the claim, of how much amount, and whether that claim is approved or claim is pending. So this is how this type of information we have. Again, in the last we have some terms and condition. Okay, so the one difference which we can see in these two documents is that document number one contains the combination of text and tables, where most of the information are structured in the form of a table. Okay, document number two does not contains any table. It simple information in the form of a text or in the form of a paragraph. So let's see how we can extract the key informations from this document. Okay, so for that I had already implemented the code in my machine. So let's give you guys an understanding about the code first, then we try to run it, and then we'll see how the output comes like. Okay, so again we are starting with the importing. So in the import we have pdfplumber for importing and reading the data from PDFs. We have spaCy, we have regex, we have globe. Again, globe is something we are using for reading the bulk of documents. So in case you have large size of documents or bulk of documents, so instead of using some specific file handling function, you can use globe. OS for defining the operating system path or directory path. Time, which is something which we are using to capture the time, overall execution time with respect to each of the documents of the complete set of process. Pandas for converting the data into and storing it into the form of a table. Collections, in the collection we are using the dictionary. Again, dictionary is something which contains the formation of key value pair. So we will using dictionary in case of merging the extracted entities with their corresponding values together in the form of a dictionary. So let's start with the configuration first. So again, as we had done in the last video, we are reading the path from where our files are contained. So this will give you the absolute path or the current path of a directory, and in that current path we are extracting the files from the src/files folder. So if you had seen, this is the base path. This will give you the absolute path, and that absolute path we are going into the files, and under files we are reading the complete set of files. Okay, so let's see how many files we have. So if you guys can see, I have 7 files total in PDF. Okay, so we are reading each file in an iterative fashion one by one, and will process the information from these files. Then we are loading the spaCy, and this is the model which we are using, EN Core Web small model we are using. Okay, we can change the model size also. You can select any of the model. If you want to understand more around how we can select any model and how we can load, you can refer to my previous section of videos. Then created a function by the name of normalize key. So this normalization function is we had created to normalize the naming space of the labels, or whatever entities NER is spaCy is extracting, so that whatever values spaCy extract, for each value spaCy tag that with his own nomenclature. So in case of the, let's suppose he's find some name, right? So it will tag that entity by the name of person, where person is in capital. So we don't want that. We want to be in small letter. Okay, if it has been tagging the organization by the name tag org, we don't want org. We want organization. Date, we want something like this. GP is again geographical, is the spaCy nomenclature, but we want it in the form of a location. Money, we want this. Product, we want this. Cardinal, we want something like this. So depending on your use case, depending on your requirement, you can normalize these mappings based on your understanding, or whatever type of information you want this complete extraction to be stored. So you can name their your own fields using the normalization function. Then we are mapping, calling the mapping function, and mappings we are getting each entity the label, and then if we are getting any entity from the text, we will normalize it with the specific label. If not, we will mention it by the name of a none. Then, as I mentioned, we are using globe, and in that globe we are passing the complete path of our folder where we have all the files, and from that in that folder we are specifically wants the set of PDF files. So we had given the extension, so we will have the list of PDF files. Again, we want to store the, let's suppose, files in some output folder, so we are creating the directory also. Okay, and then we are also capturing the length of PDF files. So as I told you, we have total 7 PDF files, so that's what we are capturing over here. And now we had started the execution. Okay, so what we are doing, we are iterating over all the PDF file one by one. So this is our file 1, we are processing it, and also we are capturing the time. So for capturing the time, we had given the start time, and in the end we will be capturing the end time. So again, pdfplumber.open we are calling, and this open will read our PDF file in the form of PDF, and then from PDF we are calling the pages, which will give you the pages. So we are iterating over each page, and from each page we are calling the extract text for extracting the text. Okay, and appending that text in the in the variable text. Okay, then we are not calling the tables, we are just calling the extract text function for in this loop. Then we had initialized the NLP. Okay, if you look into the NLP, so NLP nothing is the whatever model you had loaded, we had reference it by the name of NLP. Okay, so don't get confused with the NLP. So it's just simply the referencing of your model of your spaCy. So in that spaCy model, we are passing the text. Okay, whatever text we had extracted from the pages, from each page complete text we are passing, and we are assigning into the variable document. Then we are creating the default dictionary. Okay, and now since we already given the text to document, so what we want, so whatever processed has been done by the spaCy, so we are retrieving the entities from the document. Okay, so we can say that a single sentence may have number of entities, so that's why what we are doing, we are iterating towards each entity. Okay, so doc.ents will give you the entities. Okay, so for each entity we are calling the normalize key function, and in the normalize key function we are passing the entity dot label. So this will give you the label, that whether that name Shobhit Tyagi is a name or something else. So whatever tagged value associated with my name Shobhit Tyagi, it will pass into the entity dot label. So this will give you the normalized value. Let's suppose we are passing the name in capital, it will give me the name in small letter. Okay, so if we have found any value, okay, then yes, we are appending it. Okay, so what we are doing in the dictionary key, with respect to that key means the person, we are appending the specific value. Okay, and we are stripping the trailing the spaces, blank spaces from the end. Okay, so this is how things are working with respect to each of the set of entities from the complete page. And then once we have the entities, we are sorting those entities in a specific order, and we are joining it with the help of a semicolon. Means let's suppose we had found multiple entities by the name of name, right? So we are combining all those entities value together and associating it with a common tag person. Okay, that's what is happening over here. Then again, we are also created a regex fallback function, which will help us to identify that whatever entities, whatever patterns, whatever value our NER failed to recognize, on all those things we will run our regex pattern also. Okay, what is this pattern? You can check my previous video to get understanding about what this pattern is talking about. So then we will have such set of pairs, and for each set of pairs we are replacing stripping the replacing the value blank new line character with a blank space, or splitting cleaning the text, basically retrieving the clean value, and again we are storing that value with respect to the each label. Okay, now we want to see that what values NER has NLP has extracted, or spaCy has extracted, and what values our regex pattern has extracted. So for that, what we had done, we had created a set of the value. So whatever entities we had extracted, we are calling dot keys, and same for NER, and then we are taking the difference of both the sets. This will give me the left or the values which are in regex but not in NER. Then we are printing all those things. We are printing the spaCy one, we are printing the regex one, and then we are finally printing the missed one. Okay, and finally we are combining all the entities. So whatever regex entities we had captured, right? So we are merging it with the NER one also. Then whatever complete entities we had extracted, we are storing it in the form of source file. Okay, and then we are iterating it and appending all the rows in the variable all rows. And finally once we had completed all the iteration toward each document, we are combining all the rows into the data frame using pd.data, and the pd.toCSV is helping us to store it in the form of a CSV. Okay, so that's what the code is. So it's very pure, very basic, simple code, which is simply doing the data processing and transforming into the NER. So let's try to run this. So let's see what we have. Okay, so as I told you, we have total 7 PDF and we are processing each PDF one by one. So in the first PDF, spaCy was able to recognize these entities, and in the regex, it is able to identify these values: e policy, document policy holder, policy number, provider, plan type, premium amount, insured. So all these values, or you can say the entities, has been identified by the regex. So it seems like our regex is working pretty good. That's cool. Then we'll see what has been missed by spaCy. So you guys, if you can see that policy number, information, renewal due date, policy start date, policy holder, premium amount, all the key information has been missed by our NLP or by our spaCy. Same thing is happening in the document number 2, same thing is happening on document number 3. But the good thing is that with the help of our regex, we were able to capture the value. So if you see in the third document, we were able to find out the pre and post premium breakup, rider, claim charges, date, signature, and all. So this is how we are storing the extracting the information from the document. So now let's look into this CSV file to check what we have extracted in this document. So for that, let's go to the we have extractor. In the extractor, go to the output. So the file name is universal NLP group. Okay. Let's open it. Okay, so guys, if you have seen, we had total 7 PDF files. So think of them as each PDF is a single row. So if you see, we have total 7 columns or 7 rows, sorry, and each row is representing the single document. So if you look into the document number 1, so person, if you check the name of the person, see what we had extracted: claim history, Jane Smith, sum insured. It means that that a model has tagged sum insured and claim history as a person. Okay, that's why we are seeing the person, these values in the person. Same if you look into the Allison Johnson, same is happening. Oh, see, claim amount, description, claim amount. So all these information are tagged under the person, which is not good, right? So if you see the money, so all the values where we are talking about the money has been merged together, where we are doing the combining of the information and been identified under the money. Same is happening with date. Okay, if you look into the organization, see daycare renewal information. Daycare is one thing, renewal operation information is separate thing, right? Both does not have any similarity. We can map daycare to an organization, but not renewal information. Doctor and diagnosis information, phone, rider. So if you can see, there is lot of incorrect information, or lot of cleaning of the information required to be properly extracted in the form of specific rows and column. If you look into the cardinal, so again, cardinal is representing all the numbers. So wherever we had seen the numbers in the document, we had captured those numbers and represented by the form of a semicolon and appending it all the information together. Now this is what our spaCy is extracting. Let's look for the regex one. So if you see the regex, our regex are clearly able to identify much cleaner information as compared to the spaCy. So he has tagged policy hold document policy holder by the name James Smith and Ali Johnson. Policy number correctly has been identified. Okay, provider health insurance Inc. Able to identify it. Plan type comprehensive, and or it's a family plan, it has been identified clearly. Then we can clearly see the numbers has been tagged under the premium. We can see the sum insured, policy start date, policy end date, information renewal date, and so on. So this is how this information has been extracted by the regex and by the NER. So again, it's totally depend on your use case, on your data type, because in this case we had used a very simple model in spaCy. So if you can use the higher version of the models, or you can use some more tuned model, so you will definitely get better results. You don't need to go with regex, because regex have some challenges, right, with respect to the for each of the, if the file structure is changed or mapping is changed, in that case your regex will not work. Okay, So this is how we had extracted the information, and now you can easily use this information. You can store it into SQL, and you can clearly run some set of SQL queries on top of this data, and try to see the analytics, or try to perform various analytics of the data to see that in the past 6 months how much sum insured has been taken by their customers, okay, or what is the highest amount of premium, what are the customers which is having most frequent claims, and what type of claim type is most in the demand. So accordingly the business can take the decision. Let's say they had seen that customer one, or let's suppose Jane Smith is taking more insurance or more claim in the past 6 months, or past 1 year, or past 2 year, and then based on its medical history, let's suppose he has some very some different medical history for which he needs to go take the loan in every month, take the claim, right? So in that case company can propose some better premium product to that customer, or maybe they can hire up the premium. Okay, so all those things of strategic decisions company can take with respect to this data. Okay, so I hope you guys had gone some understanding, or get some understanding about this data, and how it can be extracted and stored in much cleaner and better way in the CSV files. Okay, so I think guys this is what I have for today, and when we will be learning and doing some hands-on with GenAI models, so in that case we will be using some higher dimensions documents, or big size documents, and then we can see that we are getting much cleaner information from the data, where we are achieving the accuracy of more than 80%. okay, right? So we'll do that in the later sections when we will discuss and talk about GenAI, but for now I think this is what we have. So I hope you guys or get some clarity or some idea about this, why we do the information extraction, how can we extract the unstructured data from the documents and store it in the form of a structured data. Okay, so that's all we have. Thank you guys, happy learning, stay happy, and we'll see you later. Thank you.